In this video, we'll discuss the pigeonhole principle. Now, the pigeonhole principle is a highly intuitive idea. It's basically saying if there are more pigeons than pigeonholes, and every pigeon goes into a pigeonhole, then some pigeonhole must have more than one pigeon in it. But it turns out we can formalize this idea by just using sets and functions. So let's see what this statement is with more precise mathematical notation. So let f be a function from a to b, where a and b are finite sets, and the size of a is greater than the size of b, or the cardinality of a is greater than the cardinality of b. Then there exists distinct elements a1 and a2 in the set A. So just by distinct, all we mean is that a1 does not equal a2, such that f of a1 equals f of a2. And all we mean by that is that these two distinct elements in the domain map to the same point in the codomain, and that would be the same pigeonhole. So A is the set of pigeons, and B is the set of pigeonholes. Now, just to look at some intuition, so here in this illustration we have 5 mice, and there are only 3 cups, and our function is mapping the mice to the teacup. So we can see that when we map 5 mice to 3 cups, that at least one cup will have more than one mouse in it. But it doesn't really say that none of the cups can be empty. But you might also be wondering, well, how do we know this is going to happen? Well, we'll get to the proof of this a little bit later. But for now, let's just understand what it's saying. So it's not saying anything about none of the teacups can be empty. So it's not saying about that everything in the set B has to have something mapping to it. The fact that f is a function is what says, so the fact that f is a function from A to B, that is what guarantees that every pigeon must go into a hole. That's where a function is a special type of binary relation, where every element in the domain has to be in an ordered pair with an element in the codomain. So that's what every pigeon going into a pigeonhole is captured. And so that English language is captured by the fact that f is a function, and where a and b are finite sets, such that the cardinality of A is greater than the cardinality of B. Well, the cardinality of A greater than the cardinality of B captures the notion that there are more pigeons than there are pigeonholes. So from this we can see the set A represents the pigeons, and the set B represents the pigeonholes, and f is the function by which we map the pigeons to the pigeonholes. Now, there are distinct elements in the domain that map to the same location in the codomain. So distinct elements A1 and A2 in A. That's just saying that there are at least 2 different pigeons that must map to the same hole. So f of A1 equals f of A2 is this pigeonhole that must have more than one pigeon in it. So the more than one pigeon in the hole would be the A1 and A2 from the set A, and that pigeonhole into which they're mapping are designated by the points f of A1 and f of A2, which is the same. Okay, now let's see how we can actually apply the pigeonhole principle, but we just explained where the language, just the common sense intuitive statement, is translated precisely into a mathematical statement. So now let's see how we can apply it. So the first claim is that in any group of 8 people, at least 2 were born on the same day of the week. So whenever we want to apply the pigeonhole principle, we have to think about what are our pigeons and what are our holes. So in this example, our pigeons, our set A, is the set of 8 people. And our holes are going to be the days of the week. Our function mapping the people to the day on which they were born. So f of A is going to equal the day of the week on which person A is born. So now, to apply the pigeonhole principle, we have to consider the cardinality of A and the cardinality of B. So we know that the size of the set A, the number of people, is 8 because we're given that, and we know that there's 7 days in the week. So because the cardinality of A, being 8, is greater than the number of days in the week, which is 7, the cardinality of B, we can apply the pigeonhole principle, and from that we know that at least 2 people in our group of 8 people were born on the same day of the week. Now, let's consider another example applying the pigeonhole principle. So in this example, we have a 25 square, so a 5 by 5 grid of pigeonholes, and we have birds in each of those holes. That's what the D's represent. And we can assume that perhaps at some time of the day, perhaps at 2 p.m., every bird is going to move either up, down, left, or right. And we want to show that no matter how the birds move, we are going to have a pigeonhole with at least 2 birds in it. And by no matter how the birds move, as long as they move to an adjacent square, so either up, down, left, or right, they can't move diagonally. So how can we show that this will happen regardless of how they move according to the adjacent square rule? Now, to see this, we have to observe that we have 25 birds in total, but we have 13 birds on red squares and 12 birds on gray squares. And because we have the rule that every bird must move to an adjacent square, up, down, left, or right, we know that all the birds on the red squares must move to a gray square. And so essentially, we've set up our sets because we know that there are 13 birds on red squares, and they have to move to a gray square. And there are fewer gray squares as we observe this board. So our set A, so essentially our pigeons, are the birds on the red squares, and the holes are going to be the gray squares into which the birds on the red squares have to move. Now our function f of A is going to be the square into which the bird in the red square moves. So it's going to be the gray square to which the bird on the red square moves. And so we have this function from A, the birds on the red squares, to B, the set of gray squares. Since the cardinality of the set of birds on red squares is 13, and that's greater than the cardinality of the number of gray squares, which is 12, by the pigeonhole principle, when the birds move, at least 2 birds will move into the same gray square.